An arc fault circuit interrupter, or AFCI, is a type of circuit breaker that is designed to protect against electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge between two or more conductors. These arcs can generate high temperatures and ignite nearby flammable materials, leading to a fire. AFCIs are designed to detect these dangerous arc faults and quickly shut off the power to the circuit, preventing a fire from starting. There are several reasons why a circuit might be suspected of being powered by an AFCI. Firstly, there may be frequent and unexplained tripping of the circuit breaker. AFCIs are more sensitive than standard circuit breakers and can trip due to minor arc faults that wouldn't trip a regular breaker. Secondly, the circuit breaker itself may be labeled as an AFCI breaker. These breakers typically have a test button that can be used to verify their functionality. Thirdly, the electrical panel may have a combination of AFCI and standard breakers, with the AFCI breakers serving circuits that are prone to arc faults, such as bedroom circuits. The purpose of an AFCI is to protect against fires caused by arc faults. Arc faults can occur for a variety of reasons, including damaged wiring, loose connections, and worn insulation. These faults can create heat and sparks, which can ignite nearby flammable materials. AFCIs are designed to detect these arc faults and trip the circuit breaker before a fire can start. AFCIs work by monitoring the electrical current in a circuit. They are designed to detect specific current signatures that are characteristic of arc faults. When an AFCI detects an arc fault, it quickly trips the circuit breaker, cutting off the power to the circuit. This prevents the arc fault from generating enough heat to start a fire. There are two main types of AFCIs. Firstly, branch/feeder AFCIs, which protect the entire branch circuit, and secondly, outlet circuit AFCIs, which protect individual outlets and downstream wiring. Combination AFCIs offer both branch/feeder and outlet circuit protection. Several factors can cause nuisance tripping of an AFCI breaker. Firstly, certain appliances, such as vacuum cleaners and power tools, can generate electrical noise that mimics an arc fault, causing the AFCI to trip. Secondly, loose connections in the wiring can create small arcs that trigger the AFCI. Thirdly, older wiring with degraded insulation can also cause nuisance tripping. Fourthly, shared neutrals can create imbalances in the current, leading to false tripping. Troubleshooting an AFCI circuit involves several steps. Firstly, identify the circuit that is tripping and determine if it is indeed protected by an AFCI breaker. Secondly, check for any obvious signs of damage to the wiring or outlets on the circuit. Thirdly, try removing any appliances that are known to cause nuisance tripping and see if the problem goes away. Fourthly, inspect all connections in the circuit, including those at outlets, switches, and light fixtures, to ensure they are tight and secure. Fifthly, use a multimeter to check for voltage drops and continuity issues in the wiring. If the problem persists, it may be necessary to call a qualified electrician to further diagnose and repair the circuit. They can use specialized equipment to identify hidden arc faults and ensure the circuit is properly wired and grounded. When working with electrical circuits, safety is paramount. Always turn off the power to the circuit at the breaker before performing any work. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to call a qualified electrician. It is important to understand that AFCIs are designed to protect against electrical fires, and they should not be bypassed or disabled. If an AFCI breaker is tripping frequently, it is a sign that there is a problem with the circuit that needs to be addressed. Ignoring the problem could lead to a fire. The National Electrical Code, or NEC, requires AFCIs in many areas of the home, particularly in bedrooms. This requirement is intended to reduce the risk of electrical fires, which are a leading cause of home fires. The NEC Section 210.12 provides specific requirements for AFCI protection. It is important to consult the latest version of the NEC for the most up-to-date requirements. When replacing an AFCI breaker, it is important to use a breaker of the same type and rating. Using the wrong type of breaker could compromise the safety of the circuit. Also, ensure the breaker is properly installed and connected to the circuit wiring. Always follow the manufacturer's instructions when installing or replacing an AFCI breaker. If you are unsure about any aspect of the installation, consult a qualified electrician. In addition to AFCIs, ground fault circuit interrupters, or GFCIs, are another important type of circuit protection device. GFCIs protect against electrical shock by detecting ground faults. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor outlets. AFCIs and GFCIs serve different purposes, but both are important for electrical safety. AFCIs protect against fires, while GFCIs protect against electrical shock. In some cases, a single device may combine both AFCI and GFCI protection. These combination AFCI/GFCI breakers provide comprehensive protection against both electrical fires and electrical shock. When troubleshooting an AFCI circuit, it is helpful to understand the different types of arc faults. Firstly, series arc faults occur when there is a break in a single conductor, such as a broken wire. Secondly, parallel arc faults occur when there is an arc between two conductors, such as between a hot wire and a neutral wire. Thirdly, ground arc faults occur when there is an arc between a conductor and ground, such as between a hot wire and a metal enclosure. AFCIs are designed to detect all three types of arc faults. However, some AFCIs are more sensitive to certain types of arc faults than others. For example, some AFCIs are more sensitive to low-level series arc faults, which can be difficult to detect with a standard circuit breaker. When troubleshooting an AFCI circuit, it is also important to consider the age and condition of the wiring. Older wiring may have degraded insulation, which can lead to arc faults. If the wiring is old or damaged, it may be necessary to replace it to resolve the problem. Replacing the wiring can be a significant undertaking, but it may be necessary to ensure the safety of the electrical system. When replacing wiring, it is important to use the correct type and size of wire for the circuit. The NEC provides specific requirements for wire size and ampacity, which should be followed carefully. Also, ensure that all connections are made properly and that the wiring is properly grounded. Grounding is an important safety measure that helps to prevent electrical shock and fires. A properly grounded electrical system provides a path for fault current to flow back to the source, which can trip a circuit breaker and energize the circuit. When troubleshooting an AFCI circuit, it is also helpful to have a basic understanding of electrical theory. Understanding how electricity flows through a circuit and how different components interact can make it easier to identify the cause of the problem. There are many resources available online and in libraries that can provide information on electrical theory. It is also helpful to take an electrical safety course to learn about the hazards of electricity and how to work safely with electrical circuits. Electrical safety courses are often offered by community colleges, vocational schools, and professional organizations. When working with electrical circuits, it is always best to err on the side of caution. If you are unsure about any aspect of the work, consult a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and fires. The NEC is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years, and it is important to stay up to date on the latest requirements. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and electrical safety. It is used by electricians, inspectors, and other professionals in the electrical industry. The NEC is adopted by many states and local jurisdictions, and it is the basis for most electrical codes in the United States. When designing or installing electrical systems, it is important to follow the requirements of the NEC. The NEC is available for purchase from the National Fire Protection Association, or NFPA. It is also available online through various subscription services. In addition to the NEC, there are other standards and codes that may apply to electrical installations. For example, the National Electrical Safety Code, or NESC, covers the installation and maintenance of electrical power and communication lines. The NESC is used by utilities and other organizations that operate electrical power and communication systems. There are also state and local electrical codes that may have additional requirements. It is important to check with the local authorities to determine which codes and standards apply to a particular electrical installation. When working with electrical systems, it is important to follow all applicable codes and standards. These codes and standards are designed to protect people and property from electrical hazards. Ignoring these codes and standards could lead to electrical shock, fires, and other serious consequences. In conclusion, understanding AFCIs, their purpose, and how to troubleshoot them is crucial for maintaining electrical safety. By following the guidelines outlined here and consulting with qualified professionals when needed, potential hazards can be mitigated and a safer electrical environment can be ensured.